Alright, in this next video, this often shows up on a test question, so I would make note of this. I'm going to explain how we have again what seems to be three disjoint equations and how they really are the same thing. Alright, so first off, Pythagorean theorem. A squared plus b squared equals c squared. I hope you've heard that a million times and you don't need any help memorizing that. At some point, we do have to rely upon memory, and hopefully that's the only one you will need in order to derive these other two, which I hate memorizing. Next we have the distance formula. Geez, I remember being given this and like, what the heck? That's a lot to memorize. It doesn't even make sense. When do I subtract? When do I add? And if you have it memorized, great. The only point of watching this video would be to see how that and the Pythagorean theorem really are the same thing. And then we also have standard form of an equation of a circle. Alright, so standard form of a circle says x minus h squared plus y minus k squared equals r squared. Now, one thing I can say with all three, I notice a whole bunch of squareds, so that helps. Alright, Pythagorean theorem. We take any right triangle. I'm purposely going to draw 2 points like this, but any right triangle. Okay, and it says the sum of the squares of the legs, like A and B, equals the square of the hypotenuse. A squared plus B squared equals C squared. Well, that's great if we have a right triangle, but distance formula doesn't rely on any right triangle, right? It's a distance between any 2 points on a Cartesian coordinate system. So I have an x and a y, right? Any 2 points. I could find the distance between those. Well, if you notice, right, like my drawing is not to scale, but if you notice, this really just represents this here. Right, I could call this D instead of C, and I'm in very similar lines here. Well, I don't see a right triangle, but we could draw one in, even though, it's not necessary when I find the distance between 2 points. If I were to, call this A, and then complete my right triangle here and call this B, I now have Pythagorean theorem with a few different variables. All I did so far is change this C into a D. Okay. Other than that, I still have A squared and B squared. Now, in my last video, though, I was saying, well, how do you find the distance? Look, it almost looks like slope, right? Rise over run. Well, the distance from here to here, we subtract. And again, if these are 2 points, x1, y1, and x2, y2, and I could put values on here like my last video, like 5 and 2, then I know 5 minus 2 is 3, but that doesn't matter. To find the length of A here, I take the second x minus the first x, because that gives me this distance. Right? So instead of A, I know to find this length A here, I do x2 minus x1. Okay, there's A. Well, similarly with B, we subtract those distances, y2 minus y1. That would give me this length B. So instead of B here, I'm going to put y2 minus y1. Right? All I did is replace A with its respective value on the Cartesian coordinate system and b with its same value. I'm subtracting the distance of my y, subtracting the distance of my x. Notice, like I remember teacher saying, oh, it doesn't matter the order. Like, why doesn't it matter? Well, notice once we square it, whether I did 5 minus 2 is 3, here 5 minus 2 is 3, and then I square it, I get 9. Or if I did 2 minus 5 is negative 3, and then I square that, I still get 9, right? That's why the order didn't matter. For distance formula, Pythagorean theorem, either when we square a negative, we get positive, and therefore it doesn't matter which order you subtract. Well, it's really close, right? The last step is, well, I like D on the left-hand side better. Okay, so that's easy. And then we square root both sides. When we square root, well, square root of a square, D, which is always positive because we're talking distance, can't have a negative distance. And then there's this whole side here, right? This is here. This is here. So Pythagorean theorem and distance formula, they're the same thing. I think that helps when you go to memorize, like, where do you put the minus, where do you put the plus? Because we know a squared, right, plus b squared. Here's my plus. And therefore, distances here and here we're subtracting. Okay. Well, if we looked back at the Pythag, when I got it close to being the distance formula, this is actually really close to there. I changed the subscripts a bit, right? Instead of x2, I just called it x. Instead of x1, I called it h. So we're like, where did that come from? Let's take a look. So if I have a circle, oh, it was supposed to make a pretty circle for me and it did not. Oh well, we could pretend. It's pretty close. If I have a circle, what makes a circle? Well, the fact that from the center to the outside of the circle, which we call the radius, is the same no matter where I draw it. I could pick any 2 points, and if I draw that radius, it's going to be the same as the radius over here. So this is now a collection of points where the radius, right, is my distance from above. Here when I did distance formula, radius. Notice, here's A, here's B. So what do we have? We have Pythagorean theorem, and again, it doesn't matter where I drew this, because, if I put my radius, use a different color, here, I can still draw it, right? This radius is the same as that radius, and I could still draw in my A, and I could draw in my B. And we can still do Pythag. Now the special point here, though, is the fact that we call the circle, we call that point HK. We'll be doing a lot with HK as the year goes by. But we call that HK to now, when we have this one point, right, where we called it before x1, y1, x1, y1 is now HK. Right, this x2, y2 is now some random point that keeps changing, and hence it doesn't have, subscripts. Just like the equation of a line, our x and y changes. X and y changes. That stands for any point on this circle, right? HK is the only thing that remains constant. That's kind of like x1, y1. It is a point, and we do know that point, and it stays. It's h and k, whatever value that is. So when we go to do distance formula or Pythagorean theorem, right, I have some point, xy. To get this distance, I'm taking my x value minus h. That's a. My k, right, the b is y minus my k. There it is. It's distance formula, just written different. We don't do the square root on both sides. We'll leave it as r squared. And as we do some problems, you'll start seeing the benefit of that. Right? This is distance formula, which in turn is Pythagorean theorem. They're all the same thing, just written slightly differently. Alrighty. If you have any questions, let me know.